Good morning to you all. This is for grade 9, video 5. Today we are going to see areas of the similar shapes. What is these areas of similar shapes, right? So now we'll see, for example, 1 centimeter, 1 centimeter, right? So another shape 2 centimeter. We know in similar shapes in the sense their proportion of their equal sides are equal, or proportion of their angles are equal, or they are similar to each other. Those conditions will apply in first book or the grade 8 or grade 9 beginning. You would have studied about the similar shapes. Okay, right. Now when come to this, here the area 1 into 1 is equal to 1 centimeter square. Here the area 2 into 2 is going to be 4 centimeter square. So when length is increased by 1 or length is double, right, area is increasing into 4 times. Can you understand that? Right? When the length of the scale factor 2 and the area of the scale factor is 4. So the length of factor is 2, right? The area scale factor right? The area scale factor right? Area scale factor is by increase by 4. Can you see that? So here we were increasing the length or doubling the length, is factor of the area will be 4 times. Okay, so if you say that another way, if you want, you can say for example, right, if this is going to be 1, another one I'm going to increase like 3 into 3. So it's going to be 1 into 1 is going to be 1 centimeter square, right? Here 3 into 3 is going to be 9 centimeters. So when I increase the length by 2, right, you can see the scale factor or the area of the scale factor is increased by how many factors? 9 times, or 9 times it increases. Can you see that? 1, it's becoming 9. Okay, increasing 2 is increasing with 9. Increasing 1 is increasing 4 times, right? 1 increased by 3 times. 1 become 4. Here 1 is increased by going to be 9 times. Another 3 more times. Here it's going to be 8 more times is increasing and coming 9 times. Okay, so what actually mean by this, in the sense we have to come to the conclusion, right? Proportion of their lengths, right? Proportion, now we say this is L1, this is L2 in the sense. Proportion of their L1 over L2 will be equal to square is equal to area 1 proportion over area 2 proportion. Or else another way you can say L1 over L2 squared is equal to K squared. Okay. So another way, if they come to the volume, right, when they come to the similar shapes of the volume, right, next what you will do, same time, right, it's now when only talk about the this thing. So when come to the volume, we'll do that one, right, the same thing, only a small increase, only one change is there. Okay, right. Now we'll do an example and see how this is going to work. Okay, right. A triangle, 1 centimeter the base, and the area is going to given is 2 centimeters square. Another one is fairly big. This is going to be X centimeter, we don't know. The area is given as 18 centimeters square. Okay. Now we know that, right? Factor of proportion of their area is going to be K squared. Okay. So I'm going to use L1 over L2 squared is going to be area 1 over area 2. L1 is going to be 1 over X squared is equal to 2 over 18. So this is going to be 1 over 9. Can I simplify and say 1 over? So that I can write 1 over X squared is going to be 1 over 3 squared. Therefore, X is equal to 3. X is equal to 3. That's the only thing you have to do. Suppose they are given something like this. They are given both the sides. Sometimes they will ask you like this. Suppose they are given this is 3 and they are not given this in the sense. They are asking the area 2. So L1 over L2 squared is equal to area 1 over area 2. So 1 over 3 squared is equal to 2 over A2. So A2 is going to be, this comes 2 multiplied by 9 is going to be 18 centimeters squared. So either they will give you length and they will ask you the area. Both the length and one area they will give you and they ask another area. Or they will give you both the areas and one length and they will ask you. So in that, either two ways only they can ask you. If they say a word similar, if the triangles or shape or whatever it is, if for example, now not only the regular shape, now for example they are saying like this. Sometimes you may confuse when they are given something, right? Okay. Okay. A and B, they are similar. They said the shape, this is going to be 24. This is going to be 16. And they said that the area of the bigger one is 480 centimeters square. They are asking the area of that. So then we know L1 over L2 square is equal to A1 over A2. So bigger one I'm taking A2, right? So L1 is going to be 16 over 24 squared is equal to A1 we are going to find, A2 is going to be 480. So 82, 83. So then it's going to be 4 over 9 is going to be A2 over 48, right? So when you simplify with 3 3s are 9, 3 1, 3 6, right? So 64, A2 is going to be 4 into 16 divided by 3. So it's going to be 64 divided by 3, you get 21.3. So A2 is equal to A1 or A2 or whatever it is, A1, right? A1 is equal to 21.33 centimeters square, right? If the shape is not the matter, which way it's coming, so either shape it is. When they use a word similar, then it will be okay. You can use it wherever you want, right? So now we are going to do volumes of similar shapes. So I don't want to, so I'm only erasing this, right? Volumes of, right? Volumes of similar shapes now. So what is the volume of the similar shape? Also going to be the same way. Only thing is going to be here. Now this is going to be a 1 centimeter cube. 1, 1, 1, right? So this is going to be, I'm increasing by 2, 2, 2, 2, 2, 2, right? So the volume is here 1 into 1 into 1 is going to be 1 centimeter cube. Here volume is going to be 2 into 2 into 2, it's going to be 8 centimeter cube. Now what you can say, the volume is when the double the length, right? Volume is going to be when the length of the scale factor of the scale factor is 2 in the sense volume of scale factor is going to be 8. That's mean, so when you change into 2, it's going to be cubic. So it's very simple. Same way, if you change that, this is going to be 1 in the sense, and this is increased by 3 and 3 in the sense, 3 in the sense, this is going to be 1 into 1 into 1, it's going to be 1 centimeter cube. For that, this is 3 into 3 into 3 in the sense, 27 centimeter cube. So it's 3 times, or it's cubic times. So then what you can say, L1 over L2 proportion of cubic is equal to volume 1 over volume 2, right? Same way here also, the proportion of their lengths are equal to proportion of their cubic of the length is equal to proportion of their volumes. Okay, so in the similar shape, if they say similar, you can see that how they are used in these techniques. Okay guys, right? Okay, so I'm going to do some questions in volume also, then it will be easy to understand, right? Now they are given right, volume of this is going to be 6 centimeter, then the volume they have given 54 centimeter cube. Then the smaller one they are given, right, this is going to be 4, and they want to find the volume is, we don't know, V1 they are asking. So then we know L1 over L2 cube is going to be V1 over V2. So this is going to be 4 over 6 cube is equal to, it's going to be V1 over, this is going to be 54. When you simplify, this is 2, this is 3, right? Therefore V1 is going to be 54 multiplied by 8 over 27. 1 and 2, it's going to be 16 centimeter cube. Okay, this regular shapes. If it is the irregular shape, something like this, right? So it is like, this is the volume, huh? So they are given the volume of this is going to be 8 centimeter, this is going to be 4 centimeter, This is the volume is they are given 4 is going to be 20 centimeter cube in this. This is they are asking. So then we can do it, right? 8. So 8 over 4 cube is going to be, right? So this is V1 over 20. So this is going to be 2. So V1 is going to be 8 into 20 is going to be 160 centimeter cube. Okay guys, so I'll be uploading the questions of volume in the similar shapes and the similar area, right? So then we are completing space and shape 2 under unit 2, right? So then there are some more there, right? Almost algebra is we are finished, and next is we can go to composite functions and things like that, right? Once you finish the composite function, I think I have done also the function, then we can go to the other things, right? So the graphs, tangent to the curves, the deviation, vectors, yeah, so on we can go, right? So go through this and work out the chapters, and we can finish it off soon as possible. So this is not the harder one or difficult part, it's very easy chapter, right? You guys to work with the exercise and come back to me. Only I have to say that only the grade 9 is the less response from the students. For Zoom class also only coming 2 or 3 regularly, others are not regular. Most of them don't come, right? They don't come also. So one thing I'll again and again I'll remind you, these chapters I will not teach once the school started. So I'm going to continue from where I stopped from what I'm doing in the Zoom classes and the videos. Okay, so it's important to all, please cooperate, so because next year is your exam, right? Thank you guys, God bless you all.